Hello and welcome to another video with Liah. Today I'm going to be talking about how to convert between moles and molecules using Avogadro's number. Before we begin on the practice problems, I would like to just go over some basics here. So Avogadro's number is here 6.02214 times 10 to the 23rd particles in 1 mole. Now depending on your instructor, this number could be shown as 6 times 10 to the 23rd or 6.022 times 10 to the 23rd or here as well. So these three numbers are possibilities on how you'll see Avogadro's number written out. Okay, so now for the equations here. To convert from a known number of molecules to moles, you would divide the number of molecules by Avogadro's number. And to convert from moles to molecules, you would multiply the number of moles times Avogadro's number. So Avogadro's number here, just remember, is the number of particles in 1 mole, and those particles are going to be very small, like molecules. Alright, so here we have how many molecules are in 1 mole of a compound. From our definition above of Avogadro's number, we know that 6.02 times 10 to the 23rd molecules would be in 1 mole. In this video, I will be using 6.02 times 10 to the 23rd for Avogadro's number. Now we have another example. How many molecules of barium sulfate are there in 10 moles of the compound? Okay, so we know that to find the number of molecules, we must multiply the number of moles times Avogadro's number, so 6.02 times 10 to the 23rd. And if we plug in our numbers here, we have the number of molecules will be equal to 10 times 6.02 times 10 to the 23rd. And that answer will be 6.02 times 10 to the 24th. So for this example, you can see that we don't have to worry about grams. That's something I often see some people make mistakes on, is where they involve grams, where we just need to involve moles and molecules only. Alright, so here's another example. Find how many molecules are in 2.5 moles of calcium carbonate. Okay, so one thing to point out here is that calcium carbonate is CaCO3. So this is why naming from written names to chemical formula is important, because you might see just the name written out, and though we don't need the formula for this problem, in some other questions you might need to know the formula. Alright, so here we know that molecules are the number of moles times Avogadro's number. So the number of moles here are 2.5. And we multiply that by 6.02 times 10 to the 23rd. And that will give us an answer of 1.51 times 10 to the 24th molecules. Next example. There are 5 moles of lithium nitride in a green container. How many atoms of lithium are present? Okay, so first here, the first thing we want to do is to find the number of molecules of lithium nitride. And we know that the equation says it's moles times Avogadro's number, and our number of moles is 5. So 5 times 6.02 times 10 to the 23rd. And that will give us 3.01 times 10 to the 24 molecules of lithium nitride. However, the question wants to know how many atoms of lithium are present, not lithium nitride. So we just need lithium. And if you look at this, so when we look at the chemical formula for lithium nitride, Li3N, we can see that there are 3 atoms of lithium for every 1 atom of nitrogen. And when we only have 1 molecule of lithium nitride, we have 3 atoms of lithium and 1 atom of nitrogen. That's if we have 1 mole of the molecule. So here, when we have 3.01 times 10 to the 24th molecules, then we have to multiply this number by 3 in order to get our number of lithium atoms. Because for every 1 molecule of this, there are 3 atoms of lithium. Our final answer would be 9.03 times 10 to the 24 atoms of lithium. Alright, so now we're going to jump into questions that are asking us to convert from molecules to moles. What is the correct number of moles in 6.02 times 10 to the 23rd molecules of a compound? Alright, so this is information we should already be familiar with. So here, we already said that there are this many molecules in 1 mole. So this is just 1 mole. And vice versa, we can say that 1 mole is this many molecules. Find the number of moles in 7.5 times 10 to the 21 molecules of carbon dioxide. We need to find the number of moles. And the number of moles is equal to the number of molecules we are given divided by Avogadro's number. So now we just plug in the numbers here. So the number of moles for this question will be this many molecules divided by 6.02 times 10 to the 23rd. This will give us 0.012 moles of carbon dioxide. This is just a division problem. So we divide the known number of molecules by Avogadro's number. If there are 2.7 times 10 to the 24 molecules of ammonium phosphate, how many moles are there of ammonium? For this question, we need to know the chemical formula of ammonium phosphate. We know that ammonium is the polyatomic ion, or common ion, of NH4+, and phosphate is PO4, the -3 charge. And so when we put these together, we want the entire compound to have a neutral charge. So right now, if we put 1 ammonium and 1 phosphate together, we have +1 plus a -3, which is basically 1 minus 3, which is -2. So right now, if we put 1 of each together, the entire charge of the compound would be a -2, and we want 0. So what we do here is multiply this by 3. So if we have 3 positive ones, right? Then we have a positive 3 charge in total for all of our ammonium atoms, plus a negative 3 of phosphate, which will give us 0. So our final formula for ammonium phosphate is NH4 and then PO4. So now we have 3 positive 1 charges and 1 negative 3 charge. Now let's find the number of moles of ammonium phosphate, so for the entire compound. So we know that the number of moles here is equal to the number of molecules we were given divided by Avogadro's number. This gives us 4.49 moles of ammonium phosphate. Now, to figure out how many moles there are of ammonium only, not of the entire compound, we have to do a similar thing that we did in the previous question. And that is, if there is 1 mole of the compound, then we can say that there are 3 moles of ammonium. So this 3 here at the bottom indicates that there are 3 moles of ammonium in 1 mole of the compound, or it can also say that there are 3 molecules of ammonium in 1 molecule of the entire thing. And so in 1 mole there are 3 moles of ammonium and 1 mole of phosphate. Now, knowing that, we could either write a proportion or just know that we have to multiply this number by 3 to get our number of moles for ammonium. Just to show you how a proportion would work, is that we would know that 1 mole of the entire compound has 3 moles of NH4. And then we have that 4.49 moles of the entire thing is equal to an unknown number of moles for just ammonium. And because we have a multiplication sign between these 2 fractions, we can cross multiply. And so cross multiplying would mean that we multiply x times 1 and 3 times 4.49. So in the end we have x times 1, which is just x, and that would be equal to 3 times 4.49, which is 13.47. And that would give us our moles of ammonium only. And this makes sense because we just multiply by 3. Because here, if there's 1 mole, if we multiply by 3 for ammonium, we get 3 moles of this. And over here, we just have to do the same thing. We just are multiplying by 3 to get our moles of ammonium. Thank you so much for watching this video. I hope you found it helpful. If you did, please remember to subscribe, hit the little bell, and leave a comment down below. I'll see you next time.